So we know that if you look at the overall limit, what are the indeterminate forms, that a by a is 1. So a by a is 1, we write a by a. But the point is, if we say a by a equal to 1, then you recognize the fact that it only has to be a non-zero number. So if a is 0, you can't say 0 by 0 is 1. So 0 by 0 could be anything. So that is what we'll handle in the limit. If you move to, there are other indeterminate forms. Let's look infinity by infinity. So that's another indeterminate form where the values are not clear, and it depends on the particular function also whether what value will come up. And similarly, we have other indeterminate form, 0 by 0, 0 to the power 0, 1 to the power infinity, 0 to the power infinity, infinity minus infinity, and infinity to the power 0. So if you look at these two forms, you realize that either this is a ratio or this is like power. There are more, majority of them are there, and this is like infinity minus infinity. So these are called indeterminate forms because we are unable to find the value through normal mathematics. So what do? We find out, the limit formulae which we deploy here. So we'll start with that. So here we go with the formula of the limit. So what can be the formula? So when we discuss the limit, the formulas the tools which you call conveniently, these are the tools through which you can find the value of the limit. So let's say, and these must also address all the type of functions. When I talk of functions, it's trigonometric functions, it's exponential functions, logarithm, algebraic, and trigonometric. So for convenient formula, you can always relate it to ILET. ILET is basically the type of functions which is used in the math. I stands for inverse, L for logarithm, A for algebraic, T for trigonometric, E for exponential. So these are the type of formulae functions which we'll be using. So we start here with the trigonometric functions because they are the most and simplest and most abundant, I would say. So first formula will say limit extending to 0 sin x by x, we call it 1. So sin x by x 1. So here it is important, extending to 0 refers to the fact that x is very close to 0. It can be negative, it can be positive, it can be anything. But when you say sin x by x is 1, it directly refers to the fact that sin x is equal to x. So if the x is very small, let's take an example. Sin 0.0005 will be equal to the same number. This number has been repeated here. Why? Because when sin x will be, see, remember this is only valid when the x is very small. If the x is bigger, if x is very large, so let's say sin pi by 2, you can't write it pi by 2 because that does not qualify under the limit formula. So sin x, so for sin x you can write x. So similarly, if you have sin 5x, limit extending to 0, you can write it as 5x. So it very clearly means you can replace sin theta with just theta. So that's the formula number 1. Now similarly, the formula number 2 proceeds for cos x, limit extending to 0, cos x equal to 1. It's a very, very different formula from what we have used earlier. Here, irrespective of the fact that x is whatever value, x doesn't come into picture. So if x is very small, so then cos x will be equal to 1. It's not that cos x will be equal to x. So that's a difference. But if you look at the 10x, now limit extending to 0, 10x will be equal to 10x by x equal to 1. So it's very similar to sin x. So you can say that sin x and 10x behave in an analogous manner, similar manner, but cos x behaves differently. And we also know that cos 0 is actually 1. So extending to 0 means x is very small. So x can be, as I mentioned, anything like 5 to the power 10 power minus 5, minus 6 are very small number compared to 0. And if you look at, 10x also, the similar formula can be deployed. Minus can also be taken up when extending to 0 means either it could be 0 plus h or 0 minus h. So these are the three formulae which we'll be using to understand the value of the limit. So let's say we take an example where we have both sin x and 10x, and that example we can illustrate how that will come up. So let's say we take up a question, limit extending to 0, sin 5x by 10 6x, and it's given here extending to 0. There's a very natural tendency that extending to 0, we are also assuming that 5x will be also small. So just replace sin 5x by 5x, and we do so. So here it is 5x. And similarly, we know that 10x also behaves that, so formula number 3 that we use. So 10 6x becomes 6x. Now x gets cancelled, so answer which you get is 5 by 6. So these are the 3 formulae which we have used for the trigonometric functions. Now similar formula will come up for the exponential and other formula. We'll see that. So we proceed now to see the formulae for the 4th formula, and as I mentioned that trigonometric formula has been already completed, those 3 formulas, sin x, cos x and tan x, and now we move to the exponential one. So here is the 4th formula. Limit x tending to 0, e to the power x minus 1 by x is 1. Now how does this come into the picture, and what does this mean? So we'll talk about the application side. Derivation also is very simple. So let's say if x is e to the power x, you can expand, and when you expand e to the power x, 1 gets cancelled, and then the higher powers of x are neglected, you arrive to this answer. But application side we talk about. So how do we use this? So let's say interesting fact is that this x and this number has to be same, then only you can use the formula. So let's say we take up an example, limit x tending to 0, e to the power 6x minus 1 by x. Now what will the answer? So remember here the power of e and the base denominator is different. So what do? We have 2 choices. Either you transform this particular value or you change the denominator. Obviously changing a power will be complicated, so we change this. How do we do so? We multiply it by 6, and if you do so, put a 6 here to just balance out offset. This value will come 1. Why? Because we have a formula which says e to the power x minus 1 by x is 1. It means the same number should come here and here. It's coming up here. It's 6x and 6x is coming here. So this value is 1, and so answer comes out to be 6. So that's formula number 4 for us. That's essentially giving us exponential values. We also move to the logarithm and some of the derived values for this. So here we go for the next formula. So let's say we go to the 5th formula now. If you go to the 5th formula, limit x tending to 0, log 1 plus x by x is 1. Now log 1 plus x by x is 1 is basically, if you expand, you can also get the same formula. So we have the expansion for log 1 plus x e to the power x, and that can easily be done. So if you find the value of log 1 plus x, you get this. So here also the same application which comes in the picture, which says that if this is x, then this also has to be x. So let's take we take a problem when we say limit x tending to 0, log 1 plus 6x divided by 10x. Now interesting fact is that you need to have the same value here. So what we do is we put log 1 plus 6x by 6 into 6, and this put x and 10 here. Now this value will come out to be 1, so this becomes 6 by 10. So that's very interesting, because how do you how do you make them so that they fit in terms of a formula is very important, and we will discuss this. With this formula we have completed the 5th formula. So this 5th formula, 3-way trigonometric, exponential we got logarithm also. Now the formula which we used earlier, now we can actually reverse, and 0 by 0 form also we will be discussing. So let's say we move to the next formula now. So let's say we move to algebraic formula and 6th number. So what the algebraic formula can be, and limit x tending to a, x to the power n minus a to the power n by x minus a is na to the power n minus 1. Now this formula has entirely different nature compared to others. How? Because this is the first formula which we are discussing now, which does not have x tending to 0 or similar values or boundary values like that. Here it's x tending to a, which is a finite value. That's first difference. Second difference, if you look, so this is like algebraic one, and obviously this is different from what we have done it. And so let's say if you find the problem like limit x tending to 2, x square minus 4 by x minus 2. Now this limit can be found out even without using the formula. How? We'll see that. So x square minus 4, you write x minus 2 into x plus 2 by x plus minus 2. This gets cancelled. Now put x in terms of x, you put 2 plus 2, answer comes out to be 4. But the problem comes, and that's where the formula comes into picture, is because when n gets higher. So let's say in the similar question we put limit extending to 2x to the power 5 minus 2 to the power 5 by x minus 2. Now here, if you want to factorize it, it becomes really complicated. To avoid that problem, what we do, we deploy the formula. So we have to find out the two variables n and a. N is essentially the power on n, so n here in this case will be 5, and if you look at a, the value is extending to a coming from, so a is 2. So this is the way through which you can actually calculate the values. Now we'll see 1 to the power infinity forms, how does that comes into the picture. So let's move to the formula number 7. So now formula number 7, if you look at, so what does it give? So let's say limit extending to 0, 1 plus x to the power 1 by x is, we have to find out 1 plus x to the power, and this is e. How do we get this value? We have to find out. So if this is extending to 0 means this becomes 1 and this becomes infinity. So this is the form of the 1 to the power infinity. So 1 to the power infinity basically gives you e. And as I said, the important point to understand here is, because you have to understand that 1 plus x to the power 1 by x, the same number is coming here. So let's say if you get a problem like this, limit extending to 0, 1 plus x to the power 5 by x, what could be the answer? The answer will be simply that you put 1 plus x to the power 1 by x there and then put 5 there. So that becomes e to the power 5. So then becomes e to the power 5. E to the power 5 is the answer. But remember, this can only be deployed when the form is 1 to the power infinity. We'll also discuss other areas, let's say other forms of 1 to the power infinity, so where you don't have the extending to 0 limit. So here the constraint is that you have the limit extending to 0. But the constraint could be different, extending to infinity or any other values where we can use that. So we'll see the other formula which is more generalized in the form, and we can actually break this formula onto that form also. So we move to the next formula, formula number 8. So let's say if you look at formula number 8, how does it come out to be? So formula number 8, let's say limit extending to anything a, fx to the power phi x. Now if this form yields 1 to the power infinity, then what does it suggest? It suggests that fx, the limit of fx is yielding the value 1 and phi x is yielding the value of infinity. So how do we get the value? So let's say if this is the value, then the limit comes out to me will be e to the power phi x into fx minus 1. So if you look at this value, how do we calculate? The first thing that you need to verify whether this formula will apply or not. So for that, first see that whether it's a 1 to the power infinity form where this can be deployed. If it is done. Second thing, you have to find out that answer will be e to the power phi x. Phi x will come, which is the power, and then fx will have fx minus 1. So let's say I take up a problem and where we can actually try this. Limit extending to infinity x plus 5 by x plus 4 to the power, so this becomes 1 to the power infinity x plus 3. So let's say this is the question, x plus 5 by x plus 4 to the power x plus 3. This is a very, very popular form of question for all the exams here. So we must discuss it. So this becomes 1 and this becomes infinity. So in this case, what the limit we get is e to the power phi x into fx minus 1. What we'll do, we'll find out the value of phi x into fx minus 1. Phi x here is x plus 3. So x plus 3 into x plus 4 minus 1. So let's look at how the answers will come out, because x plus 5 minus x, so x will get cancelled from the numerator. So let's say I will write here, so x plus 5 minus x minus 4 by x plus 4, and now x gets cancelled, 5 minus 1 is 4, and then x plus 3 by x plus 4, this is 1. So answer comes out to be e to the power 1, and we are getting e answer. Why the answer is e? If you look at the basics from where the answer is coming, is basically 5 minus 4. So e to the power, so general form I will write x plus b by x plus a to the power x plus c. General answer will be e to the power b minus a. Now here you have to remember the fact that the coefficient of x has to be 1, and which is very important. If it is not, take common and then do that, then transform into this form, and then b minus a. Sometimes the b could be negative, a could be negative, does not make a difference. B to the power b minus a is the answer that we will be looking for. So these are the 8 forms through which you can calculate. Other forms can be derived form of these, and with this we can calculate all the limits that do exist. You can calculate the answer, or deploy this formula, and you can get the answer. Thank you for watching the video.